Hey guys, this is Josh with the Update channel, and in this video we're going to be discussing how the common rail fuel system became the king of the diesel engines. Now this is also going to be considered part 2 of our diesel engine fuel systems course. And this we're going to be focusing on the electronic fuel system. If you haven't seen the first part of the diesel engine fuel systems course, I'd highly recommend it if you're unfamiliar with the fuel systems on a diesel engine. He goes over the basics on why they're so important. If you don't know much about diesel engines, I'd recommend my Diesel Engines 101 course, which is a series of videos I did for free on YouTube. But in this video, we're going to be focusing primarily on the three main styles of electronic fuel systems and why the common rail kind of won out over the other two. The other two being the MUI, which is MEUI, Mechanical Electronic Unit Injector, also known as Unit Injector or just Electronic Unit Injector, and the other one being the HEUI system, which is Hydraulic Electronic Unit Injector. Let's get into the topic. Hey guys, we have our dry erase board again. Now, instead of like last time where I illustrated everything while recording, I've pre-illustrated everything. Now, I'm not a professional artist, obviously, but you will understand how the system works by this illustration. This is not a common rail fuel system. What we've started off here with is a MUI, or sometimes just called an EUI fuel system, which stands for Mechanical Electronic Unit Injector, or Electronic Unit Injector. Some people just call them Unit Injector fuel systems. Generally, I just call them Electronic Unit Injector. So this is basically how these fuel systems work. And the reason why I picked this one first is if you watch the previous fuel system video, we ended with an MUI fuel system, which is Mechanical Unit Injector. The difference between those two fuel systems, this system and that fuel system, is this: an electronic control module. This is the computer that controls your injector. So let's go over the components here real fast. We have our cylinder, which of course has a piston in it. This is the piston, connecting rod. You have your cylinder head here. This is a single cylinder engine just for simplicity's sake. We have your injector depicted in red. There's a fuel rail inside of the cylinder head depicted in green. This is not the same style fuel rail you would see on a high pressure common rail system, but a rail is basically anything, just it's a port that carries fuel or fluids. This is our cam lobe, just depicted here. It's an oblong shape if you've ever seen a cam lobe. And of course a rocker arm. The rocker arms are similar on the valves generally, but usually the injector rocker arm is larger. So how does this fuel system work? So obviously you need to get fuel into the engine or into the cylinder at a specific time. So what tells it how much fuel and when to fire? The electronic control module tells this injector when to fire and for how long. How does it do that? Well, it's a very simple electrical circuit going to the injector, which is here. This depicts the wiring harness, and there's what they call a solenoid on the injector itself. That tells it when to fire and for how long. Now, what this does not control is how much pressure is inside of this injector. This injector is fed fuel in this rail from an external pump, usually called a fuel transfer pump or a lift pump, although generally the lift pump is for starting. The fuel transfer pump is constantly putting pressure to all the injectors in the system inside this fuel rail. Now, how much pressure? It varies from engine to engine. Generally, minimum of 40, usually about 100 around their PSI. Some of them can get higher. I believe the Cummins, like the ISX-15s, used to run 200 to 300 PSI, but not a ton. Remember, this is going to spray at a few thousand PSI, maybe 5,000, 6,000 PSI into the cylinder. So this pressure here, that's, we'll just say 100 PSI, is not enough to force the fuel into the cylinder, because remember, the cylinder pressures, when that piston's at top dead center, is going to far exceed the 100 PSI in here. It might be 600 PSI inside that cylinder, so obviously you need more pressure than that to get fuel into the cylinder. So where does the pressure come from to force that fuel to be higher pressure? Well, the rocker arm pushes down. This is a spring. EUI fuel systems have springs on the injectors because the rocker arm actuates, pushes down the spring, and that's what creates the pressure, the high pressure, let's say 6,000 psi, to force it in here into the cylinder. The camshaft is what forces the rocker arm up. So the cam lobe itself, just like your intake and exhaust valves, forces the rocker arm down at a specific time. That creates pressure to the injector, but the injector does not fire until the ECM tells it to by opening the solenoid and forcing the fuel into the cylinder. That is how a HEUI fuel system works. Fairly simple. So what engines had this system? Well, of course, I know CATs more than anything, but the C10, the C11, C13, C12, the 3406Es, the C15, C18, C16s, a lot of the heavy-duty CAT on-highway engines. CAT still makes engines with these fuel systems in them. Even some of the big engines, the 3500 series, they ran this style fuel system. The C15, C18s they still produce, still use this fuel system. What are some of the advantages of this fuel system? Well, you don't really have an expensive pump because nothing external to the inside of the engine is creating high pressure in the system. All you have is a small fuel transfer pump that's fairly inexpensive. Unlike the older high pressure pumps, which are thousands of dollars, this system eliminates that, which is nice. However, it does complicate things because you are now adding a rocker arm to each injector. You have a bigger camshaft now. You also have a more expensive and elaborate injector because you have the spring mechanism with the injector and the external solenoid. But all electronic injectors are going to have the solenoids now. So these generally are going to be expensive injectors that are heavier. It's a heavier system due to the addition of the rocker arms. It's more stress on your valve train. What are the advantages of the system though? These injectors, this style injector, last a long time. I've seen EUI injectors go 1,000,000 miles. I've seen the engine needs rebuilt and the injectors are still working fine. They seem to be the least susceptible to contaminants, damage, anything. They're a great fuel system. They're not great for high revving. They're not great for simplicity's sake as far as the overhead. You have to adjust this rocker arm now, so running overheads is more complicated. But in general, this is a very good, very strong, long-lasting fuel system. Before we discuss the next fuel system, there's a little segment we like to call... Now, these pictures were submitted by Chris, thank you very much, and this, all it said was, "This made a mess." I bet, look at that piston, that sucker is pretty broken. Now, the next one, he said he had to pull this engine transmission out of a wrecked truck, but look at that bell housing on the transmission. That sucker was ready to just fall right off of there. I'm surprised he pulled it like that, but didn't fall off, luckily for him, but man, that is some broken stuff. Alrighty. So, second of the fuel systems that we're going to be comparing to the common rail here. This is HEUI. Hydraulic electronic unit injector. People always ask me, hey, do you work on equipment? You know much about hydraulics? This is the most I know about hydraulics is HEUI fuel systems. So the hydraulic portion, of course, a hydraulic is a liquid under pressure generally, is what that means, but the hydraulic system it's referring to is engine oil, actually. So I guess they could have called it an EUI, OEUI, but HEUI sounds better. So HEUI is what it is. What makes it a HEUI system is this guy, the HEUI pump. So, base engine is going to be the same in all these illustrations. Of course, you're going to have a piston, a cylinder, you're going to have a cylinder head, you're going to have an ECM in all these. Electronic harness going to a solenoid. And now notice the injector is much simpler on this. There was no spring mechanism on this. It just has a solenoid, of course, and it sprays fuel into the cylinder under pressure. Notice there are now 2 ports, though, in the cylinder head, not just the fuel port. So the main differences are, this has nothing to do with the valve train. There's no rocker arm in this that actuates the injector. This system, like I said, uses engine oil. So what happens in this? Well, it still has a fuel rail feeding, we're going to say, 50 to 100 psi fuel pressure to the injector. But by what mechanism does the injector bump that pressure up to the 6,000 psi that it wants to get to? That's where our HEUI pump comes in. So this is supplied with engine oil. Under pressure, of course, what's your engine oil pressure generally? It's about 30 to 70 psi. Not enough to build pressure in the injector. So this takes that 30 to 70 psi of engine oil pressure. It then bumps that pressure up anywhere from 700 psi, maybe at idle or cranking, all the way up to about 4,000 psi. Now this is a C7 I was recently working on, and this is a HEUI pump. Notice the wiring harness going into the HEUI pump. The HEUI pump pressure is controlled by the ECM by use of a solenoid to control how much oil pressure is pushed into the HEUI rail. If you notice the small jumper hose right there going from the HEUI pump to the head, that is how the high pressure oil is fed into the HEUI oil port in the cylinder head. And it pumps that high pressure engine oil into the cylinder head, not into the fuel rail, but into the HEUI rail that's in the cylinder head. That engine oil under the 800 to 4,000 psi is inside the injector as well as the fuel, and it uses that pressure, the high pressure oil, to force a plunger to increase the pressure of the fuel inside the injector from 100 psi up to the 6,000 that it needs. Now, just like on the EUI, the ECM is not what builds pressure in the system. The HEUI pump is what builds oil pressure in the injector, which then builds fuel pressure by using that oil pressure to push a plunger down. What the ECM does is it tells the injector when to fire and for how long. Of course, the duration of how long it's firing is how much fuel it's spraying into the cylinder. You want more power, you need to fire for longer. So these systems were kind of manufacturer specific. So who used these systems predominantly was Caterpillar, mostly on their smaller engines, so 3126s, C7s, and C9s mostly, although some of their larger industrial engines did use them, but much less commonly than the smaller engines in the truck side. International, though, Navistar, they used the heck out of these systems. And from what my understanding is, Caterpillar and International actually came up with this fuel system themselves, kind of designed it themselves. So engines, a lot of Navistar engines, the 7.3 Power Strokes uses a HEUI system. The manufacturers might call it a HPOP, high pressure oil pump. Cat calls it a HEUI pump. Just nomenclatures, folks, but the fuel system works identical. So, what are the good and the bads of this fuel system? Well, it's a very simple fuel system because there's no rocker arms, there's no external fuel lines feeding to each injector. The HEUI pump, at least on the Cats, does not need to be timed or anything. It's very easy to change this HEUI pump. It's fairly easy to change the injectors. Although the injector O-rings can be a real pain to pop out the injector, but the injectors are simple, makes running overheads easier, it makes the valve train much simpler. Problems with these systems though, especially on the C7 Cats, not speaking on the Internationals, these could fail and then it would send metal particulate, or metal flakes basically, into the oil rail in the cylinder head, into the injector. Then you not only have this failed, but now your injectors have failed. You're talking thousands of dollars in repairs. So that was a problem. That was more of a problem with that specific style HEUI pump, more than the design of the engine itself. These are tricky to troubleshoot if you're not familiar with them, because you have to understand that the high pressure oil system affects the fuel side, and if you don't know how those systems interact, they can be tricky to troubleshoot. I've troubleshot a lot of them, luckily, so I'm very familiar with these fuel systems. I like HEUI fuel systems. They're very simple to work on. I understand how they work very well, and I think I'm good at troubleshooting them. As far as I know, no manufacturer is currently using the HEUI system on any production engines currently, unlike the EUI fuel system we were just discussing, which of course is still produced. These are, however, I do like them. I wish I saw more of them, but these have kind of gone away and gone over to the fuel system we're going to discuss next. All right, we've made it, folks, to the common rail fuel system. So we've moved on from the HEUI system. Might notice some similarities, or what you think are similarities to that system here. Of course, base engine's the same, cylinder head, liner, piston. One thing I did fail to mention, though, in the HEUI section part was the ECM is what controls the HEUI pump to tell it how much pressure to put into the rail. So the ECM doesn't directly build the pressure, it tells the HEUI pump how much pressure, and then that's how that system worked. The reason I mention that is because just like on the HEUI system, the ECM controls this guy, your pump. But unlike the HEUI system, where the pump was building very high oil pressure, this is a fuel pump. But not like an older fuel pump where it individually builds fuel pressure for each injector. This one just builds pressure anywhere from about 7,000 up to 30,000 psi plus. So way more pressure than any other fuel systems did. And it's building only fuel pressure. And it only supplies a single fuel line, unlike the older style fuel pumps where they had an individual fuel line that would go from each individual plunger into each nozzle. This is a single fuel line, so it gets fed low pressure fuel, we'll say 50 psi. It then bumps that pressure up from commands from the ECM, depicted by this red control wire here. It then pushes that pressure to 7,000 to 30,000 psi into this tube. The tube is known as the common rail. Common rail fuel system. That's why it's called that. That rail then feeds individual lines to each injector. Of course, this is a single cylinder engine we're depicting here, but most of them you're going to be working on are 6-cylinder engines. And this is it. Like, this fuel system basically is on tons of different engines. Caterpillars, Cummins, Detroits, John Deere's. Almost all mid-size and large diesel engines, even up really big ones like C-175s, use this fuel system. And after the common rail, it gets fed to something called a quill tube. Now, not all common rails have a quill tube, and not all manufacturers call them quill tubes. I believe Cummins calls them a fuel connector. But all it is this guy. So it generally goes through the cylinder head, and then this part has no seal. It's literally right into the injector, like this, and it feeds that 30,000 psi right into the injector. Then all the ECM needs to do is say when to fire and for how much. The pressure's already in the injector. There's no building of pressure inside the injector, unlike the EUI and unlike the HEUI system. So this one, all the pressure is built externally, and then the injector is just holding the pressure. The ECM, like I said, just tells it when and for how much. Now notice, there's still a fuel rail inside the cylinder head. Why? Can you think of a reason why, even though all the pressure and everything's already here, why would you still need fuel inside that rail? Is there pressure in there? Yes, there is. Maybe 30 to 50 psi. Return fuel rail. So, how much heat is generated here under combustion? A lot. Over 1,000 psi. Of course, the injector is exposed to that heat. And the fuel coming out of this pump can be very hot also, because remember, Anytime you increase pressure, it concentrates the heat. So these injectors can get very hot. So the reason there's a fuel return rail is not because of it needs pressure there, but it's cycling fuel throughout the injectors at all times. Now the other two fuel systems, the HEUI and the EUI, also had that fuel rail. They generally all flow fluid, more fluid than needs to be flowed to the injectors at all times for cooling of the injectors, not just for supplying fuel to the injector. It helps keep the injectors cool or cooler. They're still hot, but that is still something you need to understand. There's still fuel rail on the cylinder head, but on these systems, it's for return fuel only to help cool the injectors. It is very important though also because if you have injectors that are failing or flowing too much through them and then back into the return rail, generally the manufacturer is going to have you do a test where you measure the volume coming out of the return fuel rail to tell you if you have one or more bad injectors. So what are the advantages of this fuel system? Why not run an electronic unit injector or a HEUI system? I mean, this pressure is very high. It could be dangerous, right? Well, potentially, but there's many benefits to this system. However, there are bad things about this system too. The pump, very expensive. Of course, the injectors are expensive also. The injectors are difficult to replace on a common rail generally because, like a HEUI engine, you just pull the valve cover, you pull the injector right out. These, it's harder because you have to take the fuel line off here. Sometimes you have to take the fuel rail off, depending on how difficult this line is to get off. This quill tube, if you'll notice how clean it is, this is an actual quill tube out of an engine. Notice it's dirty and rusty here, but it's very clean here. That's because this generally is inside the cylinder head. So this, you usually have to disassemble this line, pull the quill tube out, then you can pull the injector out, which generally means you have to pull the valve cover off after. So it makes making the injector replacements more difficult. Also, sometimes the quill tube has to be replaced or the fuel rail has to be replaced depending on manufacturer. Since these run at super high pressure, that makes the atomization in the cylinder when it's firing very, very good. So these are, in general, easy starting engines in cold and hot conditions. They are efficient due to the high pressure. They run very clean due to the higher atomization. They can fire whenever the ECM wants it to. Remember, there's pressure here at all times, not just like on an EUI engine where it's when the rocker arm actuates. If the ECM wanted to fire this on the exhaust stroke, it could. Why would it want to do that? Well, maybe it wants to do a regeneration, which is where it's trying to artificially increase the exhaust temperature. It could fire fuel in the exhaust stroke. Some engines do that. That is a good reason to have a common rail fuel system. There are downsides to this system, though, outside of just making the injector replacement more difficult. In my experience, these injectors do not last as long as the EUI injectors. Now, the HEUI injectors don't last super long either in general in comparison to an EUI injector, but these don't last as long either. Since they're running super high PSI, and since they run very small orifices and control components inside of these systems, since they're very precise, they're much more susceptible to damage from contaminants in the fuel system. So if you're someone that pre-fills with dirty fuel, you're going to be wiping out your common rail injectors much faster. It takes life out of the injector much faster with contaminants than the other style injectors, in my opinion. So not everything's great about them, but they are a very good, clean running, efficient, not hard starting, but good cold starting injector design. They're not very loud either in general. This is the reason why this is the king of the diesel fuel systems. Hope you guys enjoyed this video. Thanks for watching.